Today, we welcome back Father John Kartje, and he's been with us twice before. And the areas that he talked to us about in the past were from physics to the divine, one priest's journey, and also the topic Genesis in the Bible and science. Father has an incredible background. He has a Ph.D. in astrophysics from the University of Chicago, and he has a Ph.D. in scripture from the Catholic University of America in Washington, D.C. And there are a lot of things written about him here. He's the rector at the University of St. Mary in the Lake, which is a graduate level seminary for future Catholic priests. But what interested me was that after getting a PhD in physics, astrophysics from the U of C, he could have gone on to be an astronaut. He could have taught at a university, taught physics and astronomy. Instead, as I recall, he did some sort of public service work at a hospital and realized how many people were in need and decided to become a Roman Catholic priest and go on to get a PhD in that area. He served as a parish priest in Washington, D.C. and in Chicago as well. And as I said, he is, in spite of the conflicts that I focused on between science and religion at the beginning of my talk, he stands as someone who can fuse both science and religion without any difficulty. And so we welcome back Father John Kartje.
Thanks so much, Bill. It's a real privilege to be back in person as well. If I haven't been censured by any popes yet, it's probably just because they don't know I'm here. If Galileo and Spinoza could have hidden out in the New World, they would have been much safer, I'm sure. I want to take, maybe just as a little scripture passage as a setup for what I want to speak about today, which is really at the forefront of where astronomy is at the moment, which is the recent launching and so far successful deployment of the James Webb Space Telescope. May be familiar to you. But the passage that I'm taking is an encounter between Jesus and a woman from Samaria when he meets her at a well in her region. So Jesus came to a Samaritan city called Sychar, near the plot of ground that Jacob had given to his son Joseph. Jacob's well was there. A Samaritan woman came to draw water, and Jesus said to her, "Give me a drink." His disciples had gone to the city to buy food. The Samaritan woman said to him, "How is it that you, a Jew, ask a drink of me, a woman of Samaria? Jews do not share things in common with Samaritans." Jesus answered her, "If you knew the gift of God and who it is that is saying to you, 'Give me a drink,' you would have asked him, and he would have given you living water." The woman said to him, "Sir, you have no bucket, and the well is deep. Where do you get that living water? Are you greater than our ancestor Jacob, who gave us this well, and with his sons and his flocks drank from it?" Jesus said to her, "Everyone who drinks of this water will be thirsty again. But those who drink of the water that I will give them will never be thirsty. The water that I will give will become in them a spring of water gushing up to eternal life." The woman said to him, "Sir, then give me this water, so that I may never be thirsty or have to keep coming here to draw water again." So I'll refer back to that a little bit later. As I said, we're going to talk about the impact of the James Webb Telescope, but not from the perspective of science per se, though I'll certainly mention that, but to do what I often love to do in talking about the interface between faith and science. And that's just to use the way that scientists look at the world, particularly the way they encounter mystery, as I think a way of perhaps giving a fresh lens, or at least a deepening of a maybe familiar lens of how to encounter God in the world, which at the end of the day is an encounter with mystery. And sometimes we, at least I know I, can become overly familiar with what I think I know about God. And that's always a dangerous thing. For those of you who are fans of Spinoza, you'll remember that he actually talked about God in highly stylized way. He actually used mathematics, mathematical formulas. Not that he was claiming you could somehow derive God mathematically, but he had theorems and axioms. And if you read some of Spinoza's theology, you might almost think you're reading a math paper, but a man of deep faith. And certainly that doesn't describe all of his writing. But I encourage you, if you haven't looked at some of these things, to do so. So the James Webb Telescope, well, first of all, what is it? It was recently launched, but has quite a history. The first beginnings of its inception go all the way back to 1996. And give an idea of how these things take, how long they take to unfold, it wasn't physically completed as an instrument until 2016, so 20 years in the making. And then it wasn't launched until last year. So once you build one of these things, the cost of billions of dollars, you've got to run it through a whole battery of tests, as you can imagine. And then when finally the launch time comes, you need the ideal conditions. So it was scheduled to launch, I think it was mid-2021. There was one delay after another, but perhaps very providentially, it actually wound up being launched on Christmas Day of 2021. And that, thank goodness, went off very successfully. And now it's in the process of being deployed, and that takes many months. So it's not just that you shoot it up there and then you start looking at things. All kinds of testing and calibration, and so far that's been going successfully. If you follow the news on this, and you know, you talk about we prayed for the people in Ukraine, you quickly realize how fast things can be relativized. So what maybe was once exciting front page news has rightly so been pushed way back. But nevertheless, that human desire to discover goes on. And the fully deployed Space Telescope be about 21 feet across, so a good chunk of the size of this room when it's finally deployed. So by far the largest telescope that's actually been sent into space. And why is it special? Well, its size, for one thing. I'm sure we have photographers here, and you know that generally, if you want the best resolution, you try to collect as much light as you can. And in space, that's even more so because they're looking at objects that are very, very faint. So you're literally sometimes just collecting, you know, 1 or 2 photons at a time. So you have to build up a lot, which means a very long exposure in order to build up an image. But it doesn't look in the visible light range. So what all of our eyes are attuned to, it mostly observes in infrared radiation. So as the name implies, that's in the red part of the spectrum and then beyond the red part that our eyes can see, so infrared. And these are very long wavelengths. That's what they're characterized by. And the reason that that matters is it turns out that long wavelengths are very effective at penetrating stuff like dust and gas, and as long as the object isn't too solid. But in space, very few things are solid. You know, the planet Jupiter, if we were up close and personal, mostly just looked like a cloudy region. And most of those amazing NASA posters that you've seen of, you know, dust clouds and gas clouds, if you've ever seen those, again, that's the result of sometimes week-long exposures. The density of space is incredibly small. And if you were right in the middle of one of those clouds, it would look like this room. You'd see absolutely nothing. So to really get a sense of what's there, it takes a lot of careful observing. And infrared radiation, as I said, is good because it has a way of just passing through Most of space is dust, actually, the matter in space. Most of space is vacuum, but when you come up to an object, they're not generally meteors or asteroids or solid things like that. They're dust and gas. And so for us, right, if you've ever turned your headlights on a foggy night, you know that light doesn't penetrate very far. It comes right back in your face. Well, if you had infrared headlights, it wouldn't do you much good because you'd be able to see unless you had special goggles, which is why the military and other organizations use those, but they can penetrate through that stuff and you can form an image. And as long as what you're looking at has some heat to it, then you can see what it is, like a human body. But everything in space has some temperature. You know, that nothing is just going to be completely absolute zero, as they call it. So long story short, infrared radiation is very valuable at looking at astronomical bodies. Of course, Galileo didn't have that. He didn't know about infrared radiation. Incidentally, if you go down to the Adler Planetarium, they actually have one of Galileo's telescopes. So I'd encourage you to go see it. Their sky show and everything is understandably their marquee events, but their history museum is quite impressive as well. You realize what a lot of work went into just building the first telescope. Now, with a good pair of binoculars, you can see everything Galileo saw. But sometimes, especially if you have a young child or grandchild, and they're maybe not used to looking through telescopes, just take them out with a strong pair of binoculars, and you'll be able to impress them quite a bit. You can see the moons of Jupiter. You can, if they're really strong, you can make out Saturn's rings. Certainly the moon is very impressive. If you get the right sort of filter, you can look at the sun. Don't even try it without the right sort of filter, but it's impressive what you can see. So the first light, as it's called, the very first time they pointed the telescope at an object happened just about a month ago. It was February 3rd of 2022. And that may not sound like much, but that really is the moment when everybody is waiting to see, you know, does this thing actually work at all? And so after weeks and weeks of just unfolding the telescope, you know, they aim it at an object. I don't remember what star they looked at, but they started collecting photons. And you can imagine if they hadn't even gotten to that point, there'd be a lot of unhappy people. But it's a big moment when you have a new telescope. Astronomers call it first light, the very first time you look at something. Now, that image is nothing. It would be blurry, fuzzy. You would think, oh my gosh, we've done terrible. But what they have to do is calibrate, right? Anyone who's ever looked through any sort of scope, or, you know, you've got to focus it. And so it's easy with your camera or a telescope here on Earth for an instrument this sensitive, let alone 1,000,000 miles. That's the orbit of this telescope. It's 1,000,000 miles from Earth. So incredibly sensitive, incredibly difficult to try and focus it. But that's what they do. So over the next several months, they'll work on the focusing. And you can expect about that time, so we'll probably be well into summer before we start seeing images. But this will by far be the most sensitive telescope in space that we'll have put up. So this is really the next generation after the Hubble Space Telescope. But as we said, it's the James Webb Telescope. So who's James Webb, if you don't know? He was the administrator who directed NASA through most of the 1960s. So he oversaw the lunar programs. Sadly, he ended his tenure right in 1968 before the lunar walk. But he was himself a scientist, but for any of you who are administrators, as I find myself being now, you know, I think it's kind of nice that an administrator got a telescope named after him, because most of the others are famous astronomers. So that's, in a nutshell, what the James Webb Telescope is all about. And it'll be particularly wonderful for two reasons. The first one I've already alluded to, the fact that it will allow us to penetrate through what would otherwise just be, especially in the visible light range, just fuzzy patches, you know, gas and dust. And that's especially important for things like planetary formation, because we generally think that's what happens when you have a star forming, and star coalesces from lots of gas and dust, but it all doesn't go into the star. And so you get some that's left out in the outer shells, and those ultimately condense to form planets. And so for a long time, that was the theory. Now we can actually see that happening. You don't need the James Webb Telescope to see that, but we'll be able to see it with this telescope in much greater detail. So anyone who has any interest in planetary science, it will allow us to see the surfaces of some planets that, their atmosphere occludes what we could otherwise see. So that should just be a very exciting star formation, another area. Stars begin as gas clouds, dust clouds, and so it's hard to see what's going on in the very inner regions, and this will help us see that. Most of those objects will be fairly nearby by astronomical measures. But the other range at which the James Webb Telescope will be so valuable is looking as far back as we possibly can. So it will give us a little window into the very earliest phase, or some of the very earliest phases in the early universe as just the universe is forming. And won't go into all the reasons behind that, but it turns out, after the Big Bang, there's a time period which is really critical. It's a period in which a lot of material galaxies start forming. And it just so happens that that region is more or less opaque to visible light. So if we could look back to that point, we would just see, kind of light, whiteness. But in the infrared, you can penetrate that and you can begin to see what's going on. Now, you might say, wait a minute, if that happened, give or take 12 billion years ago, how can we see anything? So it's this idea, of course, that light which began its journey takes time to travel, right? As I look at all of you, I'm seeing you in your halcyon youth days of 0.0000 whatever seconds ago, because it takes time for that light to reach me and when you see me. So you never see anything, quote, in real time, even though we use that expression. Anytime you perceive anything, it's going to be ever so slightly after the moment that those photons first started emanating. So in this room or on planet Earth, that doesn't make a huge difference. But by the time you get to the sun, I don't know if anyone knows how many light minutes away is the sun. Anyone?
8 minutes.
8 minutes, right? Which is a non-trivial distance if you think about it. If, God forbid, the sun went out right now, we'd have 8 minutes of a chilly late winter morning to enjoy before we would know about it. Now start going out, further and further and further, and that's why we talk about distance in years, so 12 billion light years, so forth. That light started out very far, very long time ago. Now that radiation was very high energy, so ultraviolet radiation, right? UV rays, we all hear about that. Gamma rays even. Thank goodness the Russians did not succeed in bombing that large nuclear reactor in Ukraine, but that's gamma radiation, a very high energy radiation, some of the radiation that would have escaped then. Well, in the early universe, that is the energy of the light that's produced. So you might say, well, what good is the James Webb Infrared Telescope going to be for that? Well, now you've got this phenomenon, again, I'll just state it as a given, but that the universe is expanding. And so what that means is that photons, as they travel through the universe, their wavelengths stretch, quote unquote. And so what starts out as a wavelength, the smaller the wavelength, the higher the energy. So these ultraviolet rays have very tiny wavelengths, but as that gets stretched out, as they move through time, they eventually pass through the visible part of the spectrum and then the infrared. By the time they get to us, they look like infrared radiation. So, again, you just sort of have to take that as a given as background physics. So as the James Webb Space Telescope is looking at radiation today that's emanated from the very earliest universe, it's going to see it as infrared radiation. So this telescope will help us see relatively nearby that amazing process whereby stars and galaxies form, or stars and planets form, and then allow us, as best as we can to date, to look at the very earliest moments in the universe after the Big Bang. So what does all this have to do with thinking about searching for God? Well, lots of different ways you could get at that. And for some people, it's just the sheer beauty and marvel of it itself, the fact that we can look out and even begin to perceive these things. And that's, I wouldn't question that for a moment. You know, when I sit down and just think about that, that can be jaw-dropping in its wonder, what we're able to do. But I'd like to push that a little bit, maybe in the spirit of Spinoza, who said, well, let's think, for him it was mathematicians, let's think the way mathematicians think. And does that add something? You know, and my big talking point is always, it's the way scientists engage mystery. Now, for some people, that makes them really turn off, and they think, well, wait a minute, you can't analyze God the way you can analyze a chemical sample. You can't put God in a test tube. And I couldn't agree more. And so I always encourage people, go out and talk to actual scientists and see how they do their work. These are not, by and large, closed-minded people who think you can take something, put it in a test tube, and understand it in all its depth. These generally are women and men who get very excited about engaging in mystery. And some of the humblest people I ever known are professional scientists. These are not, generally speaking, people of hubris who think science can just explain everything you've ever encountered. If you have that attitude, you're probably going to be a little bit of a shoddy scientist, because there's going to be a healthy level of humility. But what a scientist does is, you know, she doesn't back away from mystery, love mystery. You know, and you might say, okay, by the time they put me in the ground, I may not have figured this out, but what a beautiful way to spend a life, engaging that mystery, questioning it, trying to learn a little bit more. And so Galileo, Spinoza, all sorts of scientists whose names we'll never learn, are driven by that. And I would argue that, you know, a love of the divine is really a similar sort of love, and engaging with mystery. And the mystery of the divine, however you experience or want to talk about it, you know, I don't think anyone who has a healthy respect for that would say, and I'm going to have it all figured out. You know, it's that endless engagement with an infinite mystery that our minds and hearts are never going to fully circumscribe. But that's what draws us on, I think, because it is an engagement. It's a relationship. So I look at your covenant, right? And I just love the way that it's phrased. Love is the spirit of this church, and service is its law. But just take a step back for a minute. It's a beautiful phrase, but there's all sorts of an underlying worldview there. This idea that there is a spirit, right? There's a Geist. You know, there's something here that describes the overall perception of that which is. So love, grace, whatever word you want to use, but that somehow that is what infuses everything that is. Now, if you just left it there, that's powerful enough. Okay, love is the spirit of this church. But I think there's something inside of us that wants to ask the question further, well, what does that look like? Right? What does that look like? What is its manifestation? If this is the spirit of this church, well, when I wake up on Monday morning, you know, what decisions will I make? How will that describe our community? And so this idea that there is a law, right? Not a law in the sense of just some very rigid thing, but this idea that there's some structure. When you say service is its law, well, that looks like something. You know, if you're just hanging out watching Netflix all day, that doesn't sound to me like service is your law. So that there is a way of saying, I can enact, I can encounter, I can engage this spirit that I say somehow infuses who we are. Now put those two together and you've got the basic paradigm of good science. I would argue you've got the basic paradigm of just good thought. This idea of saying there's something that animates who I am, who we are as a community, but that we are incarnate folk, right? And we have minds, we have hearts, we're making decisions. There's a sense of this is the direction we want to go, or at least this is how we want to discern the directions that we might go. And so that structure, right? Call it if you like, that law. You need both of those. you need spirit, and you need law. So I love that that's your covenant anyways. And that's a direct touch point with science, because science is going to have this overarching sense that there is some structure to the universe. The universe can be knowable. That's one of the fundamental tenets of science, that somehow my brain has the capacity to not just observe, but discern what is really out there. And if you think about it, much of what science deals with are things that we can't directly encounter. It starts out with what we can encounter, right? Poking, prodding. Aristotle was masterful at this. Galileo is probably about the closest thing to Aristotle that you'll find in the modern era. You can't put him in a box. Philosopher, theologian, scientist, musician, entrepreneur. Little bit of a crank too, but most good observers, most good thinkers are artists as well. But and Aristotle was like that. Aristotle, every time there was an opportunity just to encounter things, he wasn't thinking, I'm a philosopher, now I'm a scientist, now I'm a theologian. He simply had that expansive mind and heart who believed the world was knowable. And then he set about trying to come up with ways of talking about that in a somewhat structured way. And it strikes me as endlessly amazing that for over a millennium, his way of looking at the world was largely directed in some sense. So this idea that there is an overarching knowable structure, all right, call that the spirit of science. Well, then what is its law? Well, what we call the laws of nature, the laws of physics. And again, if you think about it, we just take it so for granted, but that's an extraordinary assumption. It's held up to every test we put it to. But what's the furthest human beings have gone to actually touch something with their hands? How far? Yeah, the moon, right? You've all been taken in by the conspiracy folks. I see that. You're not familiar. There is this group out there that says the whole thing was filmed in Hollywood. But the moon, which is nothing, right? I mean, that if you try to draw that to scale on the universe, that's absolutely nothing. And yet, look how blithely we talk about, well, this is what's happening on the planet Pluto, and this is what's happening in the Andromeda galaxy, and then the James Webb Telescope will be claiming to tell us what's happening, in some of the earliest moments of the universe. Well, where do we get off making these claims? Because we're assuming the way a photon behaves on Earth is the same way it behaves on the moon, is the same way it behaves in another galaxy, is the same way it behaves in the earliest universe. But that's an extraordinary assumption, right? When I say that, I'm not calling it into question. There's good reasons for why we work with that assumption. But that's your law, if you like, right? That's saying, hey, I believe that the way matter behaves, energy behaves, is the same throughout the universe. And I can perceive that. When my eyes and my brain, look at that, I can actually discern what's going on. So spirit and law very much applies to the sciences. So in terms of then, just the last couple of minutes here, how to engage mystery, notice this whole idea that you can trust the unseen or the unknown can be in some ways perceived or known by its impact, right? Our eyes don't see infrared radiation. There's a long history for why we think there is such a thing as radiation that's not just in the visible spectrum. Starts with observing a rainbow or a prism, and then going on from there. But if you think about it, how did we get there? Not because anyone had, UV eyeballs or infrared eyeballs, but through a long process of noticing effects that we can perceive with these bodies, and then working backwards. So that, today we're launching a telescope, and 10 billion of your tax dollars hard at work, leading to this thing that we're confident can go out and look at things we'll never see with our naked eyes. But we've seen its effects, right? Now, talk about the divine, right? Are we ever going to fully, this side of the grave, encounter that divine in all its splendor and all its infinite possibility? I think most of us would say no. But what reason do we have for saying, there is a divine? Well, at some point, the rubber hits the road. And maybe for you, that's prayer. Maybe for you, that's the experience of love. I don't care how you want to talk about it, truth, goodness, beauty. But there are points of intersection. And at the end of the day, that's the foundation for what we talk about in encounters with the divine. Well, science uses that principle all the time. If there's something I've encountered that I don't understand, the first thing I do is try to say, well, what little bit of this do I understand? And there's never, if you can perceive it, if you can perceive mystery, then you are encountering something, okay? You can write a dissertation on unicorns and not even press nobody. If there's something, though, that you've actually encountered, because almost by definition, if you can name it as mystery, you've encountered something. Well, now you have something to work with. And so you start with what you know, and then you just take that little baby step into the unknown. That's exactly how science proceeds. Dark matter, that may be an expression you're familiar with. Most of the matter in the universe, we don't know what it is. And so astronomers, not being terribly creative, call it dark matter. But we have very good reason for thinking it exists because it exerts gravitational forces. Well, that's looking at something we can see, even though we can't see the source of it. So think just for yourself about the reasons you would give for believing that there is, divine or a spirit in the world, or whatever you want to call it, that's more than just our human faculties. Well, there's something concretely that you can point to. Moving from the known to the unknown, as I said, the need to be patient, right? Good scientists, even if they're impatient by personality, have to be patient professionally. Okay, an impatient scientist is a bad scientist. There was an old saying the RAF had during World War II. There are old pilots and there are bold pilots, but there are no bold pilots, right? And that goes for scientists as well. If you're impatient in how you work, you're not going to get very far. And that goes for any of the branches, but I think for astronomy in particular, for what we can do today. Galileo was able to make his telescope, relatively short time frame. But as I said, this idea was first launched in 1996, 20 years just to get the technology together, another 6 years or 5 years before you launch it. And any sort of encounter with the divine takes patience, right? I don't understand, why is this happening? Especially in days like today, where there's just so much suffering going on in the world. And I'm not going to suggest that that's ever going to, quote, make sense over time. But this idea of, as I'm sure many people are wondering, as they're hunkering down in basements in Kyiv and other cities, if there is a divine, if there is a God, where in the world is that presence here? But we'll never exhaust the encounter and the unfolding of what that presence is. So the last point I'll just make is that in astronomy, you only learn things by scattering. You only learn energy about the energy of a photon is when it bounces off something. And then you get a sense of how powerful it is. And that's something most people don't often think about. If you have a photon that just goes through space and never interacts with anything, it's not going to be terribly valuable to you. It's when it scatters off of dust and gas, it picks up something called polarization. The very thing our sunglasses, Polaroid, there's a reason why sunglasses are called that, because when light scatters off the ground, it becomes polarized. So just take that at face value. And I would argue you only really learn about the divine through encounter. There's no armchair divines, I think. If you are someone who's thinking about God or writing about the divine, it's because you're thinking about how does that presence manifest itself. So again, a very good touch point between science and faith.